Hello everyone, in this tutorial series we're going to be going over how to make fancy Pong in Godot 4. We're going to be going over input handling, vector math, steering behaviors, UI, data-driven design, and shader development. Let's start with setting up player controls and paddle movement. In an empty Godot project, let's start off by making some folders to stay organized. We can make one folder for scenes, and then we can create another folder for scripts. We then need to choose a root node for the paddle. Let's pick character body 2D. We could have gone for a rigid body 2D node, but that wouldn't make too much sense here since we're not trying to model something physically accurate here or use forces. We really just care about collision detection, which makes a character node a good choice. Let's start off by renaming that root node to paddle. Now we can see we get a warning here telling us that we're missing a collision shape. Let's go ahead and add one. You can see we get another warning here saying we have to actually define what the shape looks like. So let's go ahead and do that. And then we can pick rectangle here as the shape. And we'll adjust the size to be 20 by 100. So right now the character is set up to move, but we don't have a way to visualize it yet. Let's go ahead and add a color rect as a child. Color rects are just like they sound. It's a rectangle filled with a color. So then we can match the size of the color rect to our collision shape and go ahead and slide it into place. It should be at -10, -50 to center with the collision shape. Now that our node structure is set up, we can go ahead and attach a script to our paddle. Let's call it scripts/paddle.gd. And then there's some templated stuff here. We can go ahead and delete all of that. We're going to start from scratch. Next, we can go ahead and save our scene under the scenes directory and call it paddle.tszn. Hit save. Now, before we start scripting, let's go ahead and set up our input settings. So we can go to project settings, and then head over to the input map tab. Let's make 4 input actions. P0 move up, P0 move down, P1 move down, and P1 move up. These are going to be our up and down inputs for player 0 and player 1, respectively. So this is going to let us play 2 players locally if we want to. We'll also go ahead and assign keys to these actions. Back in the paddle script, let's create a physics process method. So we're going to use physics process rather than process because we're going to be using the move and collide method, which is tied to the physics engine. Just note that the physics process occurs at a fixed rate, while the process isn't necessarily at that fixed rate. Process could fluctuate based on the speed of your computer and complexity of the game. In physics process, we'll start by getting the vertical input for player 0 by getting the move down and move up inputs as an axis. This is going to return a value from -1 to 1, where it's -1 if down is held, and +1 if up is held. This also means that this value is going to be 0 if neither key is held. We'll then convert that float to a vector 2 and plug in the vertical input in the y-axis. We can then use the built-in move and collide method to move using this velocity we've created. So let's run and see what happens. Note that we're only going to run the current scene, not the whole game. So when we run, we can see that the movement directions are reversed from what we thought would happen. W would actually move you down and S is actually going to move you up. So the reason that happens is because that in 2D games in Godot, the y-axis increases as we move down. So to fix this, let's just negate paddle velocity. So now we can see that S is moving us down and W is moving us up as expected. But what if we want our paddle to be able to move faster? Well, we can make a speed variable and set it to 500 And then we can just multiply our velocity by the scalar to increase the length of our velocity and therefore make us go faster. Let's see what happens. So we're actually going so fast that we're going off the entire screen. The reason that's happening is that you have to remember that physics process is getting called 60 times every second. So really we're saying move by 500 pixels, which is what our speed is set to, but move by that amount 60 times every second. What we actually want to do is say move 500 pixels every second. So to accomplish that instead, we can just go ahead and multiply our velocity by the delta time, and that will give us our speed in pixels per second. So let's go ahead and run the scene again. And now we can see we have a much more reasonable speed for our paddle. Next, let's go ahead and set up some walls that we can use as a boundary for our paddles and eventually the ball. We'll make a new scene with a root node of static body 2D. We'll use static body because we want things to be able to collide with the wall, but the wall is never going to move. Let's go ahead and rename our root node to wall. And just like before, we're going to add a collision shape. So let's go ahead and pick collision shape as the child node. And we can go ahead and set up a rectangle shape. We can go ahead and make it 1280 by 40 so it can cover the entire width of the screen. We've also aligned the wall to the upper left corner by setting the position to 640 by 20. This will make it easier to work with once we get into the main game scene. Just like last time, we'll add a color rect as a child of the wall node. We also want to match it to the size of the collision shape. So we can resize it to 640. No, not quite 640. We'll want 1280 to cover the entire screen and 40 as the height. So this will be a good size, and this will let us drag 2 of these into the main game scene once we add that. Before we do that, let's go ahead and change the color of the wall just so it stands out a bit. Then we can go ahead and save the scene. And now, after all of that, we're ready to start making our main game scene. So let's go ahead and hit the plus button to make a new tab here. And we're just going to take a regular 2D scene as the root. We'll go ahead and rename the root node as Pong. Now we can start dragging in our pre-constructed scenes we've created. We'll take one wall over here. We can go ahead and position it at 0, 0. Note that's why we aligned it to the corner earlier. And we're going to want to drag another wall in, and we're going to position it towards the bottom of the screen. We'll do 680 as the height. Note that we get that from taking the viewport height minus the height of our wall. So we have 2 walls. Let's go ahead and drag one paddle in right now. You can position it roughly at the center of the screen. We'll make that automated later. And let's go ahead and hit play. We'll go ahead and pick our current scene as the main game scene. We'll call it Pong. And let's see what happens. So, see, it is working. It is able to be blocked by that wall because we're using the move and collide method, but we can't see both walls on the screen. To fix that, let's go to Project Settings, and head on over to the Window section. Let's change our viewport width to 1280 and height to 720. So let's close that and rerun the game. And we can see that now we can see both walls. It's able to be blocked by collision on both of them. However, if we resize the screen, it starts to not look right. This is because of the scaling method we've chosen. So if we go back to project setting and go to the stretch mode here, we can change it from disabled to canvas item. Godot recommends using this for 2D games. What this is going to do is maintain our aspect ratio, but it will scale everything to fit our viewport with black bars. And that's a good way for us to work on this Pong game. So it's looking good with one paddle. What happens if we were to add another one? I can duplicate the paddle by hitting Control or Command D on it, and I can drag it over to the other side of the viewport. So if we hit play, let's see what happens. So I'm hitting W, and actually both of them are moving up and down at the same time. It's not what we're looking for. So how are we going to fix this? Well, remember that Godot lets you export variables so you can edit them on instances. So if we go back to our paddle script, let's actually add two more variables that are both exported. One's going to be the down input, and we'll go ahead and default it to our down input. And then the other one's going to be our up input. Again, we can default it to player zero's up input. And after that, it's just a matter of swapping out our hard-coded input strings with the ones that come from the exported variables. So now that that's done, if we head back into our game scene, we can actually click on one of these instances and see the variables are exported for us. We just have to change the down and up inputs on the second paddle to the P1 versions. Now if we run the game, W and S moves the left player, up and down moves the right player. So it's just what we want. So one last thing before we go, let's go ahead and adjust our paddle positions to 30 by 360 and 1250 by 360. This will just make sure that they are the same distance from the edge. And we're going to automate that later, but for now, this will work. Thank you for watching. Next time, we're going to set up the ball of movement and collisions.